Go on to number 5. Differences between a compiler and interpreter. Okay, so a compiler checks for errors and gives them at the end of compilation, while an interpreter checks for errors line by line. Right, the next thing, a compiler creates an executable file while an interpreter does not. I don't know why interpreters create. I don't know how to compare that. Like a compiler creates an executable. What does an interpreter do? Like not create an executable? No, interesting. We take that. Explain how the assembly and linking process allow code written in a high-level programming language to run on a wide range of machines. If you have what an error list of is printed after a program is compiled for a compiler, yeah, that's cool. List of errors given, close enough. Explain how the assembly and linking process allow code written in high level. Right. What are we trying to do? Okay. Right. Assembly. This is a nice question. It's a nice question. Let's test your students' knowledge, understanding. Instead of just asking you to write out a set of code, have a nice little understanding here. I like it. Assembly converts the source code to assembly language that creates an object file that can be run on other processors because it is in binary. The linker word, what's it good by? The linker word, does it connect the resources needed for the program? We have the resources. Example, keyboard and mouse. What's that say, man? Yeah, keyboard and mouse. Right, so essentially what you're trying to say it creates a binary. It converts the code to binary that is independent of that, like not tied to that CPU, but any processor that could handle binary should be okay. So you probably want to say keywords like assembly language, like binary, hardware resources. Yeah, for 3 marks, I guess that we're looking for. Let me see. Can you put assembly and linking process make source code independent of the target CPU, allowing for code portability? Yes, you could say that, but that would probably be like 2 marks, I think. Somewhere along the line, you had to talk about the assembly language or the binary part of it, because there's an element of it where it actually turns to ones and zeros, and I guess, yeah, you had to put that. So yeah, I would think that what it does, what they want to get out there, because remember, these mark schemes looking for keywords, and because a mark scheme looking for keywords, you probably want to make sure that you put those technical terms inside somewhere in your answer. Assembly, binary, hardware resources, because that's the whole point of a linker. Yeah. Write a C declaration for a structure that holds the record of a customer. Each record contains customer ID, integer, and a balance float. Alright, struct customer in ID and float balance. I'll put bal. Close off that. Did we have to give the customer a name? No, that's all. Okay. C declaration for the customer ID. That's all we need to put. Struct customer int ID float bal, and then declare a variable. Oh no, we had to declare it here for one customer, and set record value. So struct customer Andrew, and then we put Andrew.id is equal to 1230, and then Andrew.balance is equal to 33.55. Yeah, you could use double for balance. That's cool. Float or double, they'll say give you the same decimal, so don't beat up too much. Yeah. right? Because when you're doing the structure, that's how to reference the name that you give the structure dot whatever dot balance. Part 3. Assume Andrew gets a 10% discount on all purchases. Write the C code to read the value from the keyboard that represents Andrew's purchases and calculates his customer balance based on it. Well, say that again. Write the C code to read the value from the keyboard that represents Andrew's purchases and calculates his customer balance based on the purchase. Okay. Scan F percent F and the discount. I'll put DIS for discount, I guess. Yeah. Calculates its balance based on the purchase. But if all they have is they just have a customer ID and a balance, where the purchase come in? Oh, note that the amount of money a customer has for me. Note that the balance represents the amount of money a customer has for making purchases. Oh, okay. Alright, understand. So right, you could read the value from the keyboard that represents Andrew's purchases. So we'll call this P and P for purchase, right? And then his customer balance is what he has left. Okay, so Andrew dot bal will be equal to Andrew dot bal. What we doing? Sorry, my brain kind of fried right now. It's been a long day. Right, so Andrew dot bal equal Andrew dot bal what? Oh, and he got 10% discount. Minus 1.10 multiplied by his purchase by P. Right, so his purchase, no. Now if it's a discount, it'll be 0.90. Sorry, my bad. 0.9 multiplied by his purchase. Right, so you read the purchase value, you multiply you take the 10% of the purchase value, subtract it from his balance, update his balance. Right. Oh, that was plenty for 2 marks, boy. Describe what is meant by term semantic errors. Semantic errors. What shall we say for 2 marks, boy? There's so much you could say. What are you gonna say, boy? For 2 marks, if I were to define what a semantic error is, okay. It is code that has correct syntax, but may not make sense logically. No, may not make sense given the parameters of the language. Example, and the only way I get away this is an example, because to explain semantic, I always find it to be very hard. Int A is equal to 9.63. Yeah, this will compile, but obviously it's an integer and a float that I cannot. Yeah, the best way I would see to do it is to apply example. Like correct syntax but doesn't produce the correct output. I guess so. Yeah, it's mostly like wrong data types. Yeah. So example using wrong data types. Yeah, I don't think I could explain this without an example, because a semantic error is best explained with examples, in my view. So for example, I don't see much of a problem with that. The rule of a watch in programming, it is to track the state of a variable throughout the code. Errors that occur when data types don't match the contents of the variable when initialized. I guess we could take that. Yeah, I guess we could take that. But there are other ways that semantic errors could happen. They could happen in functions also. Like you could have a function that expects 3 arguments, but you send 2 arguments instead. That is considered a semantic function. That's a semantic error too. Because the function might expect 2 things, but you send 3, and it will just be like, well, yeah, it's working still, kind of. Yeah. So as I say, it's better Yeah, that's your for example for that. I can't see a way for them. I would love to see the answer they have. When you see when you say mathematical errors, then it might be a logic error you're talking about. So, but logic and semantic kind of same. But logic could be wrong steps too. Okay, close enough. Write a function array sum which has got an integer and an integer variable clearly indicating the size of the array. The function should return. So it accepts an integer array and a variable that says the size of the array. So it returns the sum of all numbers in the array, not greater than 50. If we return any sum of numbers, is it whole numbers or decimals? Did they say? Alright, if it's not, we just put float. No, it's an integer array, my bad. So it's an integer array. Int array sum. What do we receive? An integer array. Was anybody integer? We call it ARR. An integer variable int size. Yeah. Then what do we do after this? We say sum of all the numbers in your array not greater than 50. So for C, we added the declare counter int C is equal to 0. For C is equal to 0, C less than size, C plus plus, ta-da. And then we're going to say, oh shucks, yeah, I had to put the int by the ARR, yeah, my bad. Int, because we had to make sure that is an integer array. Correct, thank you, good looking out. Int ARR, right, good. What we do now, if ARR location C is greater than 50, come on, 50, then we have to sum it. I didn't have a sum variable either. Come on, sum is equal to 0. Sum is equal to sum plus ARR location C. It's less than, not greater than 50, it's correct. Right, so it's less than 50. Semicolon, and we end up this for loop. Boom, and then return sum. It should return the sum of all the numbers in the array that are not greater than 50. That will loop through the array. You see each location, blah, 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 less than 50. If you are less than 50, you'll add it up to the sum, return sum, and close off that curly brackets there. It should say, now let's see, what did they say? Not greater than 50. I double check. Integer array, we have the integer array. The return type is int array sum cool int array ARR int size could integer variable. Look at that. Finding the size array, right? Function should return the sum of all the numbers in the array that are not greater than 50. Not greater than 50 means less than or equal to 50, because it can't be not greater than 50. Any number that is not greater. So 50 is not greater than 50. Right, yeah, less than or equal to. Yeah. Let me see what it's in there. Hold on now. Let me think again. Not greater than 50. Let's see it very slowly. If the number is 49, are you not greater than 50? Correct. If we have 51 will be accepted because all the numbers in the array that are not greater than 50. But the only way I could do this is I could just write down numbers, right? 49, 50, and 51. Okay, let's say we have this in the array. 49, 50, and 51. Bing, 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 bing. Alright, so it gets ARR location C, it gets 49. Is 49 greater than 50? No, it is not greater than 50. So 49 gets counted. Ching. Then it gets 50. Is 50 greater than 50? The 50 is not greater than 50. So ching, we'll accept the 50. Is 51 greater than 50? Yes, it is. So it's not. So 51. Yeah, so it's less than or equal to. Yeah. Because 50 is not greater than 50. Yeah, 50 is not greater than 50, so therefore 50 should be accepted. So if ARR location 2 is less than or equal to 50, it should be not greater than 50. Yeah, that's correct. Right. First that person asking curly brackets for the if. Now, if you have one statement and a if, you don't have to put curly brackets. If you have multiple statements, you have to put curly brackets. So if it's just one statement, you could just put it right after the if and it will work still. Okay? So, but, I mean, it's a good look. Yeah. What was I going to say, boy? Who's this fella, boy? Nandagopal Archives. You're coming in real hot dog. You're looking for a little band. Please keep your comments a little more civil. We don't really fight here on the live. Everybody's cool. I will listen to the students that are giving corrections and being nice about it because we don't hate. We're not very vexatious here. Okay? Alright? Cool. Yeah, but the question says return the sum of all the numbers in the array that are not greater than 50. If 50 is not greater than 50, so it should add the 50. It should include the 50. Axis of the question, is 50 not greater than 50? The answer is yes, so therefore it should be included. Please tell me you understand that. The only thing that's greater than 50 is 51. I don't need to explain anymore. Simon Williams, yeah, I understand what you're saying about the SEM question, and I think you do have a genuine argument there, because it depends on where you put the 0 bit to make the 5th bit. The fifth bit could be anywhere, but that'll be up to the CAPE examiners to determine. But as I said in the answer, the only clue that I have is that they put 5.50. That's the only clue that we have. Complete the traceable below by writing the output values of I, n, and result at the beginning of each iteration if the function fact5 is invoked by the following C function. Oh, this is a factorial question. Right, I remember they do this already in some past paper. Alright, so we're starting off with fact in n, right? Good. So 5, basically what's gonna happen, what do I need to initialize size? No, I don't need to initialize size because size came in here already. Once it gets passed as a variable, once it gets passed to the function, size already exists. So you could use it inside the thing. The only thing we had to initialize was the C being equal to 0 and the sum is equal to 0. Because those two variables we didn't get from before. And I just use our for loop because our for loop is a lot easier. Well, whenever you loop intro and our for loop is the best way to go. Alright, so back to this question. Fact 5 is coming in. So that means n is equal to 5. So result gets set to 1. Right, question is, do they want you to take into consideration the initialization of result to 1? Sometimes they don't, and sometimes they just want you to do the loop one time. So I'm going to 1, 2, 3, 4, 5. Right, they don't want you to take into consideration that result is 1 at the start, so let's just jump straight into the loop. For I is equal to n, I will start off at 5. N will start off at 5. Because 5 is what we get. Result is equal to result plus I. Result was 1. 1 plus 5 is 6. Cool. And we'll look back up again because this is a reverse for loop, so it's going down I minus minus. So I minus minus will be 4. N has not changed. N is always 5, and yeah, N is always going to be 5. They're not going to change it anytime soon because 5 came in, 5 will go, 5 will stay. So it'll be 4 plus result plus I, 6 plus 4 should be 10. Then we go 3, 10 plus 3 should be 13. 2, 13 plus 2 should be 15. 1, 15 plus 1 should be 16. I think so. I'm gonna double check it. So fact n comes in as 5. 5 is invoked by the following function code. So 5 comes in. Fact n is going to be 5 all the time. Result starts off as 1. For I is equal to n. I and n will start off at the same value. I will start at 5. N would have been 5 all the time. Once I is greater than or equal to 1. Cool. I minus minus. Right. Okay. So there are 2 reasons why I can't put the result as 1 to start off, right? Because they only give me 5 lines and it's 5 loops that are taken, right? And then right. Yeah, so we can't put the 1 because they only give us 5 spaces, and they said they want you to show the result at the beginning of each iteration. So the beginning of the iteration is, the first iteration is when you start to check I and n is equal to 1. So it would start off at 5 because the actual process of the iteration would be for the 4. You understand? Like the iteration begins when the for loop starts. So you'll have to put it like that, and they only give us 5 spaces. If we had put the 1 inside, yeah, if we had initialized the 1 and put it inside, then we would not have space because we'd have reached down here and the 16 would not be able to fit. Yeah, I know result is 1 before it starts looping, you know, but they said, and the result at the beginning of each iteration. When does the iteration start? The iteration starts here. So the result after the iteration starts would be this first result here. So that'll be the first value. And as I said, they only gave you 5 lines. If you put 1, then you will end up missing out. Yeah. So don't, if you had put the 1 inside, you'd get 1, 6, 10, 13, 15, but then the 16 would never be able to fit. And the 16 has to fit because it counts. Look, the question with this paper that I have here, this black market paper, it missing the question with the asterisk. So I don't know what that question looks like, because it went from number 4, it went from number 4A and went down to number 4C. So we have a little problem there. I'll probably add again next paper. A next paper for it. Well, I don't know if I'll see if there's another paper, but based on what I heard from the asterisk question, wasn't that hard, I think. Yeah. If you lose marks for not including the 16, I believe that you will lose marks for not including the 16. Yeah, I think so. Because remember, as I always say, these examiners have a particular answer sheet to look at, and their answer sheet will be 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this. So you have to have a whole correct line in order for it to count. So it will look like that. Right? So alright, that is it. Alright, so let me just scroll back through and I'll tell you some of the points where it will be contentious, right? So the contentious things in this paper, if there are any, which I don't think is too much. Most of the worded stuff, fairly straightforward, so let me go through. Question number 1, no contention there. RAM and ROM, straightforward. Switch protector, voltage regulator, no problem. Supercomputer, microcomputer, no problem. This one here with the CPU, the specifications for a gaming computer, yeah, there'll be some contention here because there are so many different specifications that you could put. I'm guessing that they will have a lot of answers that they will look for. So hopefully they would see the logic in what you're saying more than looking for particular words, right? So that one is contentious. Fetch, decode, execute, straightforward stuff. Multiplexer, straightforward. This diagram, straightforward. No problems there. This one here, part C, this contention, yeah. Here's why the contention will come in. Because when you have to get the 5-bit mantisser, you will end up only getting 1. If you just do the normal 5.5, you'll end up getting 101.1. But it's 5 bits for the mantisser and this is only 4. So after you move the thing here, you can end up moving it 4 to the front and you'll get 0, 1, 0, 1, 1. This could be the mantisser. Right? If that's the mantisser, then your exponent will end up being 1, 0, 0, which equates to binary of 4, which equates to decimal of 4. So because you move 4 spaces to the left. Could be. Why I believe that the 0 has to go at the end is because they put 5.50. So that's a clue to say, okay, if you put 5.50, then that 0 had to go at the end there, so then you end up with your 5 bits with the 10110 there. That's why the exponent I have is 3. And they've asked this question in the past to do the opposite. And when you do the opposite, you just end up putting the 0 to the end to make up the 5 bits all the time. So that's the contention. I don't know what they will do. I suspect that the examiners will have to make some sort of concession or some sort of understanding for it. But if they do argue for it, the only argument will be that they put 5.50, because normally they don't put a 0 at the end of a decimal. Alright, I hope that explains that. The 2's complement is fairly straightforward. You get the binary value of the number, then you input it, add 1, and it'll end up adding it, no problem. Top down and bottom up, 2 marks, nothing to fight down there. Problem definition, analysis, identify and evaluate, and what each one of those is 4 marks, 1 mark each, no issue there. This one here, there's not the contention of this is this part here where they have separate bill is needed for each restaurant. Because it said separate bill is needed for each restaurant, it makes you think that you have to do some kind of calculation for Jamaican bill, Barbadian bill, Trinidad bill, and then add them up, which is possible depending on the type of question that you'll have to write out the bill for each one. But then they ask you, then they tell you what they want you to do. They want you to just calculate one single bill for a single customer. So they didn't ask you about the bills for each particular restaurant. If they ask you about the bills for each particular restaurant, you write a total different program, but just for a single bill for a single customer. The customer comes, you say, hi there customer, what do you want? You ask for the menu option, you get the option, you make the choice that you want, you do your calculation, the bill gets updated, and you keep looping. And the option to exit the pseudocode perfectly lined up with the concept of doing a while loop to make sure that the person doesn't enter 0, right? So we get the information, we loop through it, yada yada yada, ting, and then you check to see if the number of meals that you would have added up. Every time the loop runs, you carry up the number of meals by 1, and then you carry it up, and then print your bill as bill. And you go. Alright, number 4, now issue there. No unbounded, reduce by 5. This, find any errors here, not a problem, unless you try to fight down to use mod. And well, the star question obviously is missing because you all know it had a star question, but I don't know where that is. And then programming, right? Compiler and interpreter, no problems there. The assembly and linking process. This one, I'm not too sure what the wording for this will be. I can't say for sure exactly what they'll be looking for with the wording, but I know it has 3 marks, and when they have 3 marks, they're usually looking for 3 key points. So your 3 key points will be assembly language, somewhere inside there. Something to do with binary, something to do with resources, and then you're trying to show that it's independent of the CPU. And then, well, the structures question, no problems there. The structure declaration there, structure calculation could be a little tricky if you do the 10% properly, but that's okay. And then the last 2 semantic errors, right? This one here is contentious too. Like defining a semantic error without using an example is pretty tough, but you should get through if you had an example. The rule of a watch, no problem. And doing this, I'm positive, sure it's supposed to be less than or equal to 50. ARC is less than or equal to 50. Sum is equal to sum plus ARC. Yeah, less than or equal to means 50 is not greater than 50, so therefore 50 is supposed to be accepted because while it's equal to 50, it should count. And then this one here, the problem with this is that some people might put the result as the first value, but they said at the beginning of each iteration. So at the beginning of the iteration will be after the for loop does, then it will be that. That'll be the beginning. All right, so that's the solutions there as best as I could see. Hopefully I'll get an answer sheet or somebody who marks will be able to tell me exactly about the contentious things, but for the most part, that would be the solutions that I would give if I were writing the exam. Cool, so thank you very much you all for coming, and thank you for those of you all who were correcting little errors along the way and giving your inputs, and I hope that I answered as much of your questions as possible. All right, So that's all, folks. You're welcome. For those of you that are doing IT,